Assalamualaikum warahmatullahi wabarakatuh. We meet again in video materials for physics class. Now, today I will explain about heat. Before I explain further about heat, first I will explain about temperature. Now, how can temperature be measured? The concept of measuring temperature is using zeroth law of thermodynamics. The law states that two or more objects that have different temperatures will reach thermal equilibrium with each other. For example, now I have a thermometer with the initial temperature is T1, and then the temperature of some object here is T2. Now, if I bring the thermometer close to the object, now the thermometer will adapting with the object. So the scale in thermometer will raise up if the object is hot or if the object is cold. The scale of the thermometer uh, will be lower, will be low down, because there are different temperature of these two objects, the thermometer and the object that we will measure, because there are different temperature or delta T, so they will reach thermal equilibrium with each other. Now, for thermometer, we can use some thermometric properties. So the temperature itself can affect the physical properties of materials. So these properties will be utilized for the concept of thermometer. So the concept of thermometer is utilizing the thermometric properties of a materials. Example of thermometric properties is thermometric properties are dimension. The dimension like length, area, or volume, or it could be electrical resistance, gas pressure at constant volume, and etc. And then the thermometer scale that we will measure, actually we can calculate with this formula. So because the temperature depends on the variable x is refers to thermometric properties here, so it can be dimension or electrical resistance or etc. So the x is the temperature that we measure, the measured temperature, and xs is the reference. Now, example of thermometer is, we know that liquid thermometer is the common thermometer that we use daily basics, like these figures, because this thermometer using alcohol as the thermometric properties. So if this thermometer used to measure some object, if the object is hot, the alcohol and mercury in this thermometer will rise up, because there is expansion, the thermal expansion. The other liquid thermometer is constant gas volume thermometer. It using thermometric properties of gas pressure, or we know that common use for industry is thermocouple. Now, for example, I have a platinum with the resistance is 19.35 ohms. The thermometer using thermometric properties of resistance, electrical resistance. So this thermometer is used for measure some object, and it shows a resistance of 110 ohms. So with previous formula, because temperature is the function of X thermometric properties, so because here we use resistance, so we change the X with R. Now we substitute the R with 110 ohm divided by RS, the resistance of platinum, the reference is 90.35 ohms. So now we have that temperature of the object. The measure is 332.57 Kelvin. And now for some thermometer in some region in Indonesia, we use the Celsius scale, and for in United States of America, they use Fahrenheit scale, and the international standard is using Kelvin unit. With this unit each other, for each unit we can convert the unit from Celsius to Fahrenheit, or Celsius to Reaumur, or Celsius to Kelvin, or the opposite, from Fahrenheit to Reaumur. How to convert this unit of thermometer? First, we need to know in the difference of temperature. In Celsius, the difference of between the water, the ice cube start to melt down is at 0 degrees, and start to boiling is at 100 degrees. So the difference here is 100 degrees, and the symbol is delta Tc. And for Reaumur scale, the ice to start to melting is at 10 degrees, and the water start to boil is at 80 degrees. So the difference here is delta Tr is 80 degrees. And then in Fahrenheit, the ice start to melt is at 32 degrees and start to boil at 212 degrees. And the difference temperature here is 180 degrees. And in Kelvin, the low temperature is 273 degrees, and the high here, the water start to boil, is 373 degrees. And the difference temperature is 100 degrees for Kelvin, delta Tk. Now after we know the difference temperature here, we can write down the scale comparison. So we use this Celsius divided by delta Tc is equal to the temperature in Reaumur, R, divided by delta Tr, equal to F minus 32 divided by delta Tf, equals to K minus 273 divided by delta Tk. Now for Fahrenheit and Kelvin, these two units is there are minus 32 and minus 273 for Kelvin. Why? Because in this unit, the starting point is not 0. In Fahrenheit, the starting point is 32, and Kelvin is 273. So we need to make all of these units is similar, start from 0. So for the Fahrenheit, we need to subtract with 32, and the Kelvin is subtract with 273. Now we substitute its difference temperature. Now we have this last equation, last formula here. This comparison, scale comparison, we can use it for convert from Celsius to Reaumur or etc. For example, we know the temperature in Celsius is 25 degrees Celsius. Okay, now how much the temperature in Reaumur? So we can use these two comparison. Yeah. We can write these two comparison by C per 5 equals to R divided by 4. So we substitute C with 25 degrees here, with 25. Yeah, divide by 5 equals to the temperature in Reaumur that we need to know, divide by 4. Okay, we use this basic mathematics. This is 5, this is 25, so we simplify this. Now we have 5. We multiply 5 and 4. Now we have that the temperature in Reaumur is 20 degrees Reaumur. Now for the second topic is thermal expansion. So if I have some object, I heat some object with a certain temperature, the dimension of the objects will be changed because of the environment temperature changing. Now we call it thermal expansion. In thermal expansion there are 3 kinds of thermal expansion. The first is length expansion. Yeah, this expansion is happened for the object that has length dimension, and if the object has dimension, area dimension, like a board or a window, etc., or plate, if we hit this object, it will expand. So the expansion is area expansion. And next is if the object has volume dimension, so there will be a volume expansion. For length expansion, we can calculate delta L, or the change in length is equal to alpha multiplied by LO multiplied by delta T. Alpha here is a length expansion coefficient. This coefficient is different for its materials. And next is for the difference in area, the change in area of some object. We can calculate with this formula. Yeah. Delta A equals to beta multiplied by AO multiplied by delta T. Yeah, so the beta here is area expansion coefficient, and for the volume expansion coefficient is gamma. And we can calculate the difference of the changing of the volume of the object, or delta V, is equal to gamma multiplied by VO multiplied by delta T. Now next is heat concept. So we know that thermal equilibrium can be achieved because there is a flow of heat. Rumford and Joule made a statement that the heat flow is nothing but an energy transfer. So if I have 1 calorie 1 calorie is the amount of heat required to raise the temperature of 1 gram of water or substance by 100 Celsius at 1 atmosphere pressure. The heat capacity is equal to differential of Q by T, dQ or dQ per dt. Q here is the heat, and C is for heat capacity of the object or materials. And the specific heat is C, the little c, is equal to C capital divided by M. M is for the mass of the object. Or we can calculate the total heat needed by an object to change its temperature is with this formula. Q equals to M multiplied by integral of C dt. The integral is from T1 until T2. Actually, we can simplify this equation to just Q equal to MC delta T. For this note is the specific heat itself. Actually, the specific heat here actually depends on temperature, but for more easier to understand, we can assume a constant specific heat. Next is about Black's principle. So, if some object has a higher temperature and the second object has a lower temperature, if I combine these two objects, so there will be a combined temperature, or the higher temperature of the object will be release the heat, and the lower temperature will absorb the heat. Okay, they will absorb. Based on the Black's principle, we know that Q, the calor absorbed, is equal to the heat absorbed is equal to heat release, and the heat flows from high to low temperature. Okay, so if I combine these two objects, the heat flow will be like this. Yeah, from the high temperature on top to the lower temperature at the bottom here, and we have the combined temperature Tc. Okay, the combined temperature is will not less than T2, but the combined temperature will not be lesser than T2 or higher than T1. So it's from T1 until T2. And now phase change. So there are two types of calories, or there are two types of heat. The first is heat to increase the temperature, and the second one is heat to change the phase of the object. Now we know that water, if I froze the water, so it will be solid phase, right? The solid phase is at below 0 degrees Celsius. So if I have ice cube here, ice cube. So I heat the ice cube. So there will be increasement of temperature from TA to TB. So here is a temperature for this is the heat to increase the volume. So the heat is equals to the mass of ice multiplied by the specific heat of ice multiplied by delta TAB from here to here. Okay. Now after this, I heat again I continue heat this ice cube, so the ice cube will be melting at this temperature, but the temperature is constant and the phase will be changed from solid to liquid. So this is the process of liquidify or melting process. The heat for melting or for changing the phase of the object is equals to ice, mass of the ice multiplied by L. L is melting latent heat. Okay. Now if I continue heat the water, now the temperature will be rise again. At Tc. So there will be a heat to increase the temperature. The heat is QBC equals to M water multiplied by C water, the specific heat of water, multiplied by delta TBC. If I continue heat this object, now there will be process of evaporate. So when the water vaporizing to water vapor, the heat needed is equals to the mass of the water multiplied by U. U here is evaporate latent heat. And if I continue heat this water vapor, now it needs the heat to increase the temperature, or QCD here. And the Q total is QAB plus QB plus QBC plus QC plus QCD. Now we need to understand that for its phase, it has a different specific heat. Like in this area, the materials, the object is in solid state. So the specific heat we use is ice. But here in this process, because it's already all the ice is already fully melt, so we use the specific heat is for water. So, but the mass of the object should be same. From the mass of ice is equal to mass of water. And the next is calorimeter. Calorimeter is some tool for measuring the heat capacity of an object. So I put some object here, the sample here in cup. So I heat it with by ignition wire, and this is water. The water will stir by some stirrer here, and there is a thermometer. So by Black's principle, Q absorb is equal to Q release. Now we have this equation. With the W notice for water, C here is for cup, and S here is for sample. Okay, sample. Now for heat transfer, we know that heat flows from high temperature to low temperature as long as there is different temperature. The heat will always be flow from object with higher temperature to the lower temperature. So the flow of heat, or the heat flow, we can calculate by this equation. The heat flow is equals to differential of heat by the temperature, or dQ per dt. There are three types of heat flows or heat transfer. The first is conduction, the second one is convection, and the third one is radiation. For conduction, the heat transfer is through a medium. the medium, yeah, like a solid. So if I have some stick from iron, steel means steel bar here. So if I hit this point, the heat will be transferred from this point to other side of the object here. So heat will be flowing from the higher temperature to this is the higher, this is the low temperature. Okay, we can calculate the heat transfer. H is equal to minus Ka multiplied by dt per dx. The differential of temperature by x. X is the length of the object, right? Or we can simplify this equation by H is equal to minus Ka delta T per L. L is for the length of the object. K is for the conductivity of materials. A is for the surface area, and delta T is the difference temperature. With this A here, the surface area. So if I have some tube here, if I hit the bottom of the tube, the heat will be flow from bottom to the top, right? From bottom to the top. So the surface area here is the bottom part here, or the top part here. This is the A, the surface area. So because as long as the area of the object is constant, there is no changing in surface area, we can use this formula. We can use this simple formula. So this is the area, the surface area, and this is the L, the length. And for the convection, the heat transfer is due to the transfer of matter. So transfer of matter. So there are molecules or part or atom or part of the object. So the convection is happened for fluids like gas or liquid. Yeah, because for convection transfer is due to the transfer of matter, because there are displacement of the matter, the transfer of the matter. And the last one is radiation. The radiation is a heat transfer without an intermediary. This is by radiant. So if I have a fire camp and there is someone here, so the person here can feel the heat from the campfire by the radiation. So it will be radiation. It's enough for today's explanation. I'm sorry if there are some mistake from me or some mistake from my explanation. Thank you for your attention. We will meet again at other video materials for physics class. Thank you. And for some example or some question example will be explained by different video. So thank you once again. Wassalamualaikum warahmatullahi wabarakatuh.